this out. Here's how you do scientific notation. If I have the number 500, 500 can also be written as 5 times 100. Do you agree? How are we doing with that? All right, good, good, good. 100 can be written as 10 times 10, or 10 squared. Fair enough? All right, so the scientific notation for 500 is really 5 times 10 squared. Dominique, Danielle, have you seen that before? I'm almost sure Isaac has. All right, Danielle? Okay, good, good, good. Then I can kind of move on with that. The beautiful thing about scientific notation is it turns these crazy multiplication problems into, well, into easier multiplication problems, and essentially, like with dealing with the number of zeros, that really helps out. Like, for example, if we're talking about like the size of the earth, the weight of the earth, the mass of the earth is 5973600000000000000000000 kilograms. That is pretty ridiculous. Like, imagine if I told you, okay, now take that number and plug it into your calculator and then multiply that by whatever and then divide by this and then divide by that and multiply that and then square it. You would have to write down that number so many times your hand would get sore and you would get lost and you would be angry and you'd be frustrated and all of that kind of stuff. So what we do in science is we shorten that. We kind of do a shortened notation. And this shortened notation isn't just because we're lazy. It actually has other uses as well, and I'll get into those in just a second. But essentially what we do is we say, okay, how many oh gosh, you already got it for me. All right, good. So it's actually 5.9736 times 10 to the 24th power, because if I were to move this decimal place 24 times to the right, I would get that number up top. Are we cool with that? And good counting, by the way. All right. So what about like the mass of an electron? And I'm actually kind of pleased because we're getting through this thing at a nice brisk pace. So it looks like we'll be okay. The mass of an electron. All right. Atoms are made up of really small things called protons, neutrons, and electrons. Electrons are really small. They're even smaller than the protons and neutrons. The mass of them is 0.000000000000000. You can see the number. I'm not even going to say it. So in order to do it that way, what you kind of do is you count like you go like this. All right. How many times would I have to move the decimal place backwards in order to move it, or actually this way, in order to make it at least reach this point right here? And that answer is 31 times. If you want to count it, you can. So all you do is you go 9.12, and I'm going to round it off to, actually, that's a 9.11, isn't it? If I rounded it. Times 10 to the negative 31. Because if I took this decimal and I moved him 31 times to the left, like it's telling me to do, I'll get the number above. Do you agree? Good. Good, good, good. That took us 5 minutes to do those 3 example problems. Essentially, scientific notation is all about this. It's the C times 10 to the E. The E is called an exponent. It's a number, an integer. The C is called the mantissa, or the significand. And after you heard me say that, you don't need to memorize that, because that doesn't really matter. It's apparently the significand is not really that significant. Just know that it's a number. And in scientific notation, what we usually like to do is we like to have just a number, and then we put a decimal, and then put the rest of the numbers. Okay? So that's what we like to do. So when you do scientific notation, that's what you're going to try to do. Did I go too fast on that one, or are we cool?